So first of all, on this example, a couple things that they're asking us to do. And you guys will need to remember these things for when you guys take the end of the year course, end of the year exam, as well as we are taking a mid-year exam, like the first 2 weeks of December. So these will probably definitely come back up. So first thing, guys, remember, here is our general form in vertex form. Here's your equation. The axis of symmetry is simply x equals h. That's it. So all you need to do is determine what h is. Now remember, h, it's x opposite h. So in reality, this can be written as x minus a negative 2. Right? It's x opposite h. So we need to write it in form of subtraction. So x plus 2 is written as x minus negative 2. So therefore, my answer is x equals negative 2. Please note, it's not negative 2, or it's not just negative 2. The axis symmetry is a line, right, that the graph is symmetrical about. So to represent it as a line, we have to represent the equation. And it's a vertical line. So it's x equals negative 2. The next thing is identifying the vertex. What we love about vertex form is the vertex is really easy to identify. It's just h, comma, k. Well, k is negative 6. We already know h is negative 2. So my vertex is simply negative 2, negative 6. The vertex is a coordinate point. So therefore, bless you. So therefore, that's why we use our parentheses. Does that make sense? OK. The vertical transformation, which I'm just going to do is VT. Well, ladies and gentlemen, if you remember, the parent graph starts at 0, 0, right? The parent graph. If you were just to grab y equals x squared, that's at 0, 0. So now, if I'm changing that vertex to go down 6 units, I have now shifted my graph down 6. So we can just say down 6 units. OK? The horizontal transformation is going to be how far we're shifting our graph left to right. So again, the vertex is at 0, 0. But now the vertex has been moved over 2 units to the left, right, because it's at negative 2. So therefore, we would say left 2 units. Does everybody understand? Anybody have any questions? The next thing is going to be compression or stretching. And you can write this in a couple different ways. But you guys remember, compression and stretching deals with our letter A. Remember, if A is positive, the graph opens up. If A is negative, the graph opens down. But that would be a reflection. In this case, we have 4. And if you guys remember, when we graphed, when you have absolute value of A, sorry, that's really the absolute value of A, is either greater than 1 or the absolute value of A is less than 1. That's how we determine the stretching or compression. When the absolute value of A is greater than 1, what that does is that compresses it horizontally or stretches it vertically. You can say either or. So I'll just say stretch vertically by a factor of 4. OK? Or you could say compressed by a factor of 4 horizontally. The next one is going to be domain and range. Well, everybody in this class should remember domain and range, or especially domain. Domains for quadratics. Quadratics always expand. Doesn't matter if they open up or down. They always keep on going expanding. So therefore, they represent all the x-coordinates. So the domain is negative infinity to positive infinity. To find the range, though, I told you didn't have to graph. But I think it would be important to kind of know what the graph looks like to identify the range. So to identify the range, we know our new vertex is at negative 2, 6, right? OK. Does the graph open up or open down? Up, because 4 is positive, right? If 4 was negative, the graph would open down. So the graph opens up. It looks something like this. So when we're identifying the range, we're looking for the lowest y value to the highest y value. The lowest y value is the y coordinate of your vertex, which is negative 6. The lowest this graph goes is negative 6. Since negative 6 is a point on the graph, or a coordinate on the graph, we say it is included. So we use a bracket. Well, how high does this graph go? Up to infinity. You cannot include infinity, so we use a parenthesis. OK? Is that enough information for you guys to do the other problem? OK.